I see 5 likes.
We are live right now. Cool.
Okay.
Oops, we're in the middle of the presentation. Okay, let's wait for 1 more minute. During this time, I will present our guest, Leonid Melnikov, who is a Java enterprise developer.
Yeah. Hi, Andrew.
Hi, Leonid. Okay, let's start. Today, our topic is Git Workflows, and I will make a disclaimer. There is no perfect Git workflow right now, and you need to find your own for your project, because projects are different and requires different workflows. But luckily, we already have a basement for them. And what we are going to do today, we will start from few currently existing workflows. We'll take a look and we'll think if it applies to our project and which pros and cons of those workflows. Also, we will learn some tools if someone not familiar yet, and we will create our own workflow, which for sure will suit our application. And our hypothetical project will be a web application, and the team will consist of few developers, project manager, and quality assurance person. And our goals for our workflow will be the following. We will need to create some clear interaction model for people in our team. For example, if new person or new developer comes to our team, he can read the document and be ready to work with other colleagues. We want our commit messages be homogeneous, like they will be written in similar way, and you will have easy time reading the history of all changes in your repository. Also, we want to group commits by feature because it will make a context available for every commit. And we want a clean commit history with explicit merge commits in master branch, which will be done from feature branches. And we want a simple branching model, as less additional and auxiliary branches as possible. And some quality requirements. Everything in master will be deployable, and we will be practicing continuous delivery. Leonid, can you mute your mic while you not talking,
Yeah.
please?
Yeah, sure. Wait a second, please.
Thank you. And code must be reviewed because before it goes further to production, and feature must be after tested, and feature must be tested by quality assurance person. And having all those requirements, we can take a look at already existing workflows and check if those workflows suits our needs or not. Actually, it's what the heck happened here? Sorry. Actually, those goals can be different for your project, but I took them for example of our hypothetical project. And first of all, in most workflows, we will be using one of those tools or both of them for different purpose. And here I pasted the link, which has pretty good in-depth review of both tools and which use cases suitable for them and which pros and cons do they have. And simplest Git workflow is we try to escape anything dangerous like rebasing, interactive rebasing, rewriting history, and all such things. We're doing some commits. We don't care about the content of commits. We don't care about commit messages. We create branches whenever we want, and we merge everything to anywhere. And after that, we ask someone smart to understand what is going on with our Git repository. Sometimes it works, and sometimes it doesn't. And probably you need to something more well-defined. Actually, if you work on your own and you have only one contributor, you can use master branch and commit directly to it. If you have a few rare contributors, you can cherry pick the changes or somehow merge the pull requests and don't care about workflow at all, and don't figure out anything that went wrong, because when you have so little interaction with other developers, you probably won't mess anything in your Git repository. But if you have at least few developers, you already need some workflow. Hello guys, hello Gleb and Sergey. And first workflow, which was defined around 10 years ago, was Git Flow, and it's really well-defined workflow, but it has some disclaimer here, and the disclaimer says that this workflow not suitable for current state of art. It's not suitable for web applications with continuous delivery and many other projects, but it was suitable for example for Linux distros which has release cycles, and you have a master branch which contains those releases, and those releases prepared during some time in release branches, and development happens in develop branch using feature branch which is merged to develop branches, and some hot fixes backported to release with minor version and to the develop branch. Yep, and that's a little complex for our use case because we want to keep the number of branches as less as possible. But it's still pretty viable workflow for some cases, but for not our case. And here you can see some pros and cons that are written today, and it may be helpful for you to get a basic understanding of what is good about it or what is bad about it. The rule of thumb that if you have explicit versions like Ubuntu Linux, which has 16.04 version and 16.10 version, and it released 2 times per year, probably this workflow will be good for you. But for our simpler web application, it won't be. It will be overkill. That is why we can look at much simpler workflow, which called GitHub Flow, and it has pretty neat description, and the idea very simple. For each feature or fix, you create a new branch, you add few commits with the changes, you're creating a pull request, you discuss your changes with your colleagues, doing some additional changes during this discussion. After that, you're doing testing or deployment to staging server or something else. And after everything checked, you're merging this feature branch to master. And every time your master branch is ready for deploy. This workflow, very simple. It's very easy to use. It requires very few Git commands to implement such workflow, but it has some cons. It's not very flexible. It doesn't describe how you deploy, how you test, and what you do. For example, if your pull request lives for a long time and there is already new changes in your master branch, and you can't merge with them without conflicts. Do you need to rebase your branch, or do you need to resolve a conflict, or do you need to pull updated changes from master branch to a feature branch, and so on? Those questions are not discussed in this workflow, and if we do only things described in this workflow, we will get a pretty branchy model at the end of the day. I will show the example of jekyll repository, which shows how long-listing branches pollute your history, and it's a little harder to find the context of changes of particular commits. But it's very simple and good starting point if you only starting using Git. Another pretty simple but still powerful workflow described by Atlassian company in their blog, and it's called simple Git Workflow. Oops. It uses rebase, and it describes those edge cases. It has a few steps, a little more steps than GitHub Workflow, but still understandable in few minutes or a few dozens of minutes. You creating a feature branch as in GitHub Workflow. After that, you creating and adding commits, and you from time to time rebasing your feature branch on the master branch. Rebasing is action when your base commit changes to the last commit. For example, you created branch from here, and there was few changes you made, and after that someone added changes to the master branch, and you need to get those changes in your feature branch. You can merge your master branch to a feature branch, or you can rebase your feature branch on the latest commit of master. And in this workflow, the after proposed to rebase your feature branch on the end of the master branch. And when you are ready with your changes and you want to get feedback or to discuss your changes with your team, you pushing your branch and doing something like creating pull request or starting email thread or whatever you use for discussing your changes. After discussion, you can add commits, but for now you can't rebase your branch because it can mess if someone else will decide to add some changes to a branch if it allowed by your workflow. And if you're very experienced, you can rebase, but better not to do it until you get very familiar with how Git works. And especially don't use force flag because it will mess up the history of the other person. And if he is not familiar with Git enough, he will had a hard time. And after you finished and everyone stopped committing to this branch, you can rebase your branch on the latest commit of the master, and you can create a explicit merge commit using git merge no ff and with your branch. This will make your history almost linear. You will have a master branch and feature branches which merged every time in master branch with explicit merge commit, and you will be able to see every commit of this feature in context of this feature. I will show later on our practice part of today's stream.
Andrew, can you explain what's main difference between rebase and merge, git merge?
Yeah.
And when we prefer use other ones, each other?
I placed a link in the slides, and you can find it and read in more details, but the simple answer will be the following. When you're merging something from master to your feature, for example, you create a merge commit which contain all the changes from all those commits from master in one commit, and your feature branch will still be placed in the same place, but with additional commit which accumulates all changes from master branch. But with rebase, as you can see on the picture, you just reapply all the comments of feature branch on top of your latest commit of the master.
Okay, thank you.
Okay, let's go to pros and cons. This workflow suitable for relatively small teams. It described with enough details about Git and how to use it, and in which situation what you have to do. History is pretty good. Probably it's one of the most interesting part of this workflow, because this workflow generates very readable history. And one downside, maybe there are other downsides, like it requires some additional effort to do so much rebases. But one of the disadvantages is that this workflow requires a deeper understanding of the Git. And the last one for today, but I think there are much more other workflows described in the network, but those are main and most popular, I think. It's a GitLab workflow. It's described on GitLab site, and it contains comparison with other workflows like GitHub and Git Flow, and also it references even simple Git workflows that we discussed before. It adds much more information about how to work inside your team, and it has a lot of tips and tricks here, but from my opinion it's not very well defined. What I mean that it has a lot of you can do this or you can do that. That will make it harder for a new person to come to your team and cooperate with you, because he won't be sure how you do it in your team. That is why it's more like document for ideas which you can pick for your workflow rather than well-defined workflow itself. And one interesting point that I realized some time ago, that it's better if your workflow grow with your team. When you need something, you introduce it to your workflow, and when you don't need something, you remove it from your workflow. And here sample script that will help you get the repository which we will be using for our demonstration today, if you need it. But you can just watch what we do. And let's start from investigating in our tools and why we so care about the history. I will start from the latest point here in the list. It's blame and time machine. I will be using Emacs, but you can use any other Emacs with magit plugin, but you can use any other Git client, graphical or CLI, it doesn't matter. Almost everything what I do here possible with those graphical clients or even with CLI client. Actually, CLI client is pretty powerful, but you have to type a lot of things. Here I will be using shortcuts instead of typing, but you will be able to see which commands necessary to type to implement such features. And first feature is looking at history of the project. You can see when some change was introduced, and you using this hash of the commit, you can see exactly what was done by this commit. Pretty basic feature. You can implement it using git diff and git log commands. Hello, Jerome. Yep, and another important feature of good commit history that you can do a blame on the file. the blame shows which part of the file was introduced by which commit, and also you can see the related changes for this commit. For example, you're curious what also changed during this commit, and you can see it here in the Git diff. You can do it with CLI client, but it will be much harder. That is why I'm doing it with Emacs client for Git. And another interesting, maybe not so important, but very neat feature, it's Git timemachine, which requires to go through the all versions of this file and look how this file changed during development. We can see the log for this file. It contains only commits related to the changes with these files, and we can navigate through those commits using timemachine and see how this file changed comparing to previous version of this file. Sometimes pretty useful feature, and it's very useful when you're trying to investigate who introduced and for what reason those changes was introduced to this file or to few files connected somehow with each other. Let's go to the next tool, which called stash. Let's open our test project. For now, it's very simple Python application, and stash is another feature pretty neat, which allows you to store your changes in some special place without committing those changes to any branch. And I can use the stash to take every change from the stash and apply them to current working directory. But also, if I need to do some changes with commit history or something else, I can make the special thing called stash. And those changes will disappear. As you can see on the left, the files changes when I apply stash and move all staged and unstaged changes to the stash. Probably I need to say what's the difference between staged and unstaged changes for people who not very familiar with Git. When you trying to work with Git, before committing, you need to add files somewhere, and this somewhere called stage area or index, and this file not staged, not added to index, and this file is added to index. And if I will do commit right now, only those changes will go to commit. And let's create a separate, let's move all those changes to stash. Let's create new master, new branch from master. Let's call it add length and name CLI arcs. And let's pop our stash here. And let's make a commit. As you can see here, I implemented reading arguments from command line at CLI arcs for name and length. It's pretty big commit because we implemented two features at once, and later maybe we will do it in a different way when we will be cleaning up our history. But for now it's okay. For now, it's our draft of the branch, which is not pushed to anywhere. That is why we are good to go with even not so good commits. And we modified readme and said now it accepts two CLI arguments. Good. And now we want to commit. Before committing, we need to stage those changes. After that, we need to type commit message. Updated readme nd. What wrong with this commit? Now we can see we have two commits in our branch. The bad thing about this commit that we misspelled our verb because it has to be in present tense. Why it should be in present tense? Because we need to define the rules which we use for our commit messages to make our history more readable. And the simplest option is to use this article and follow it. The other option, you can define your own rules and stick to them. And we can do very simple thing. We can call command git amend, which will ask us for new commit message, and it will update your last commit with new commit message. All the comments that I used for all those sections are visible here on the left side. And if you want to understand how it works, you can stop the video later when it will be a video and to look at them closer.
Andrew, can we use commit amend for latest commit or not, or only for first one?
We can use amend only for updating the latest commit. For example, if we made a mistake in commit message, or for example, we wanted to commit something else. Now it's much better. For example, we wanted to add this sentence to our README, but we forgot it. We can stage those changes, and we can call commit amend with no edit flag, and it will update the latest commit with 2 lines instead of 1. But it works only for a latest commit. If you want to update history for few commits, we will need to use interactive rebase. Interactive rebase allows to do batch editing of commit history. You just select the region which you want to edit, and it will prompt a list you with a list of commits that you want to edit, and you need to change the verb near this commit, which says what you want to do with this commit. And also you can reorder those commits to make them ordered in a different way. And let's add one more commit, which, for example, fix something in our code. Oops. No, this one. This file contains trailing white space. I will remove it, and I will commit fix trailing white space in main.py. Yep, and now we, when we are ready to share our changes, first of all, it's a good idea to rebase our branch on current master, but we worked on the latest version of the master and we don't need to rebase it right now, but it's a good idea. If master changed during your development, you can fetch the master and rebase your branch on the origin master, And in this way, you will get all those changes from master branch to your feature branch. And after that, you can push your branch to remote repository. And now I can, oops, misclicked. I can type my git link or something. Yep. And open this link in my browser. And here are my changes in this branch. And I'm able to create a pull request, which will be reviewed by my teammates. And I can check if pull request contains all the changes that I wanted to introduce. I want to see that commit history pretty clean. We added all necessary functionality, updated README, and even fixed something. And I creating pull request. After that, I can somehow say to Leonid that I want his opinion on the changes. And maybe if he wants to introduce some changes, he can commit something. Leonid, can you share your screen?
Yeah, sure. Okay.
Oh, now
Okay,
you can
can you
see.
see?
Yeah. Can you move it to the right because it's
It's
what
better?
yeah, much better. And can you show us how you will start to work with our repository?
First of all, I need a link for Git clone.
Yeah, you can open github/abcdw/git something. Oh, you already have this link.
Yeah.
And you can yep.
On it. Okay, let's start. Okay, let's.
Actually, you can review our changes even without cloning it using web interface or email client. If you open your email client, you will see the message about pull request.
Yeah, I can see it. This one. Yeah.
Yeah, you can look at the changes that was introduced by this in the file changes tab.
Okay, I see it.
It's only one commit.
No, I think it's three commits here.
Yeah,
I see.
Look at files changed tab. At the right. Yep. No. Files changed.
Files changed. Sorry, I can see.
The fourth step. Conversation commits checks.
Yeah.
Yep.
Yeah.
And here you can see all the changes, and you can see that we use Добрый день here, but it's probably better to use Привет or hello. You have two options right now. You can write a comment for me that you won't see a different word here or different phrase here, or you can change it yourself.
Okay, I think I can change it by myself.
It's also a viable option.
Okay, let's change it.
Okay, for that you need to check the same branch, which called add length and name.
I think now I'm on master. Yeah. Check out to which branch, Andrew?
Add length.
Okay. Add.
You can, after complete it, probably with.
I think. No. No,
you can copy it from here. Oops.
I can see. Okay. I
Okay.
think it's clear. Okay.
Cool.
Yeah. Let's.
Now you can introduce your changes.
Yeah.
And update
Main part.
greeting message for Russian language.
Yeah, this one. Yeah.
Yep.
It's okay. Yeah.
Yep. Good.
I think now we can check.
Yep. Everything correct.
Okay. Next step we should commit. Yeah. Yes. A and M. What message? Okay.
Change greeting message.
Yeah.
Yep. Cool. And now you can push it. For those who are not familiar with flags for git commit, first flag -a makes all unstaged changes to be added to commit, and -m means message. And now you can push your changes to remote branch.
Origin, I think. Yeah.
Cool. I will go to my browser and we'll see what happens here. I can see that you added new commit.
Okay.
I can see that it was changed. Actually, I can see exactly what you changed watching your commit. And let me pull your changes to my local repository. Now I can see your commit. And also let's find let's update our readme. Change greeting message for Russian language. Cool. We updated our readme. Update readme. And now we have history of commits in our branch and everything fixed that we wanted, but there's some problem with the history. We have a misspell here in the message for this commit. Also, we have a pretty big commit that we want to split into different, because it introduces both features. First one for the name and the second one for the language. And that is why right now I will do interactive rebase, which will allow to do a few different things. First of all, I can move the order of messages.
Andrew, what you should do now, I think you should use Git rebase, yeah?
Yeah, I use
what command you use?
Git rebase -i. But I use it in my text editor because it's a little more easier to use it from text editor rather than from command line for me. And what we'll do, actually we can abort our rebase if we did something wrong, and go back to our current state of the repository. I made it a little bigger, the font in terminal, and I hope you can see it right now. But if we know what we do. We can continue. For example, I want to 1 second, update readme, my latest commit, correct. I want to merge all commits related to updating readme in one commit, because it's kind of logical not to have few different commits for the same action. And here I reordered commits and placed update commit near each other. And now I can squash latest commit into previous one. That will make only one commit from two commits. And we can finish our rebase here. And it will ask us what we want to do and which message we want to keep for two commits. I want to keep only update readme md message and remove update readme message, and we are finished. And now if you look at this commit, it contains all the changes to readme done in the whole branch. Pretty good, but interactive rebase much more powerful. We can reorder commits, we can squash them, but also we can change wording for commits. For this we will be using reward. And also I want to edit this commit. I want to split it into different. And also I want to squash the commit with fix of trailing white space in the previous commit, which introduced this white space. It makes sense because, yeah, you don't need to separate commits for that. And let's start our rebasing. First of all, we will be stopped at our @CLI args for name and length commit. And now rebase stopped, and we can continue or abort this rebase if something goes the wrong way. But we will do following. We will reset the head of our current state. That will remove the latest commit, which is @CLI args and so on. And will show, because we will be using soft reset, it will show all the changes that was done by this commit. For resetting, actually magit has pretty good cheat sheet which shows all the hotkeys available, and we will use git reset, and we will be using soft reset. Actually, to make you see what is happening here, here on the left you can see what happened in last few seconds. And now we will do a reset. We will do Shift X soft, and we will be resetting. Here we have an argument for reset command. We can pass a commit hash, we can pass head and some additional symbol which describe in which direction we want to shift our head. For example, we can type head -1, like previous to the latest commit, or we can type a master or any other reference for any commit. Let's use the current commit -1. That means that we will remove the latest commit. Bam. And now we have all our changes staged and ready for commit. And now I want to unstage few of those changes. For example, I want to commit first changes related to the language. Oh, to the person. Let's unstage the change related to the language. Those changes, and those changes. Now we have only changes related to person name. Because person name is the first argument, it's logically that it should be committed first. And let's commit it. Add person name argument for our CLI. And let's stash our changes for a while to make to remove them from our working directory. I stashed them, and if we look at our let's go to the directory with our test project, and if we look at our main.py, we can see only changes related to person name, and let's check if main.py will work with name argument, and it works. Cool. And if you provide a language argument, it doesn't change. Okay, now we can take our changes from the stash. For this we will use git stash apply. Now we have our changes for the language, and now we can pass a language as argument to our CLI utility, and now it works. Cool. And it says Dobry день because there is no fix for Dobry день phrase yet, but it will be introduced later during our rebase. And we can check if it works for Leonid, and it works for Leonid with Russian language. Good. And now we can commit it. Add lang support for our CLI arcs. Now, instead of one big commit with all those features, we created two separate commits. Actually, this example doesn't require, but if you have a huge code base which has a lot of features which introduced in one commit, it will be hard to, for example, revert this commit if it introduced some bug or something else, because it will affect so much features that you won't be able to easily revert it.
Also, Andrew, can you fix error for my commits? I use great, not greeting.
Yeah, you can see that here we have a reward, and during our rebase, when we continue our rebase, first of all, we will squash commit related to trailing white space to this commit, and also after that we will be able to reward your commit message. Okay, let's continue our rebase. And here we see the squash that we already saw, and we want only this commit message because this one introducing some real changes and this one is fixing, and we don't want a separate commit for it, and we just remove the commit message. Good. And now it asks us to change commit message for Leonid commit. And actually, during this rebase, the aftership of this commit won't be changed. It still be Leonid who introduced this commit, but I will be a committer who actually made this commit. And here we can, for people who are not familiar with commit messages, we can provide additional information here. Actually, we can write a poem here because it can be as much lanes as you want. But it's better to have a separate empty line between commit message and your additional comments to this commit. Okay, we made the commit, but the problem now is that we have unpushed changes to the remote branch and unpulled changes from remote branch. This happens because we have to separate branches. First one our local, and the second one remote branch, and they have different commits inside it. And actually it's pretty different branches, but I want everyone to know my branch, my latest changes, and my rewritten history as a original branch. And I will push, but I will push with force. I will need to put force flag, and after that I will be able to push those changes. If I will try to push my changes without force, it will say that it failed because blah blah blah. And that is why I add force flag, push my changes, and here we go. Our changes successfully pushed, and now I will be able, to see all those commits here. And actually you can see that previously latest commit by Leonid became but last commit, and files changed, seems the same as it was before I rewritten history, but now this history make much more sense. And after everyone during conversation said everything that he want to see in this feature branch, I will be able to merge this branch. But before merging, it's a good practice to know that this code works. Here I did a manual testing executing our code, but it's a good idea to have automated tested that will be run on each push to remote branch. And for example, if you don't want to changes be retested, you can pass argument to commit message like a simple string, no CI or something like that. That will prevent triggering the build and triggering tests if it takes too much time. But in most cases, it's good to have those automated tests passed every time you push to remote branch. Another idea that another thing that we can do before merging this feature branch to master is deploying it to special environment which can be tested by quality assurance person. For example, we can have a separate server for staging environment, and we can deploy to it from any feature branch. We can do it in a different way. For example, the simplest one that you can do, you can trigger your CI using git tags, and here in history I can place a tag on the latest commit and type something like v011 minus r1, and this minus r1 will make sure that it's release candidate or something that's not suitable for production, or something that is almost ready for production but don't have to be deployed to production. And when I placed this tag on the top of my feature branch, I can push this tag. I can push all tags, and I'm not sure that it will appear here, but here I can find tags, and we'll see this tag, and CI will be triggered, and everything will be deployed to a separate instance. And after that, I can say QA to test all my changes. And after he made a manual or automated testing of those changes, I will be able to merge all those changes to master branch. And when we will be merging, we can do it through web interface, or we can do it using git merge no ff. Both options are viable, but this one is easier because it just typing, clicking one button and typing commit message. Now we merged this feature branch to master branch, and we can even delete our feature branch. And let's go back to our master branch. And let's pull all the changes from original repository. We have two options here. We can pull every time from original repository, and in most cases, if we don't commit to original repository, we will get fast forwarded and all changes just will apply on top of our current branch. But if you do some changes to a branch and after that pulled, the remote branch will be merged with your local branch. And if you want, instead of merging, to reapply your commits on top of remote branch, you need to place rebase flag. On the links that I put in the slides, you can find the information about rebase, and it's git-rebase.io site, which explains how to use git pull with rebase and why you can prefer it instead of git with default merge behavior. But for our case, it doesn't matter which pull we will use, but it's nice tip. And now we can look at our history. And this history is great because it's pretty linear. This development was done by only one person, and it was a linear history. And if you work as a one person on the project, you can just commit everything to master. And when you people are coming to your project, you want to make commits in isolated branches. You can do it on your own, but when you work in the team, it's much more important. And all those changes related to this branch will be visible as a list of changes which going one by one. They not spread it in the time in your history. They here aligned and ordered because we rebased our before merging our branch, we're basing it on the latest master. That that means that if we even started this branch from this commit before actually merging this branch, we first rebase it on the latest master, on the latest commit from master, and after that we create explicit merge commit, which says that all those changes will be introduced to master. And now this master ready to be deployed to production in case of our simple web application. But if you want a more fine-grained control over deployment, you can create pre-production, production branches and merge from master branch to pre-production first, and after everything works and you're sure, you can merge those changes to production. This approach described in GitLab Workflow. Or for example, you can tag those commits with different version. For example, it will be 0.1.1 and I will one more time, tag 0.1.1 and EV require me EV uses after completion. Okay, for the simplicity, I will call it differently. Now we have this tag and we can push it. And now CI can trigger build and deploy to production. And for comparison, I will show the history of jekyll project, which is static site generator. If And we can see that all commit messages look the same. Some of them skips CI, as I talked earlier, because, for example, updating some documents doesn't require to run your tests. But if we scroll down through this history, oh, it's big history, it loads. You can see here the branching is pretty similar to what we saw in our project, but in earlier stages of the project we can see that it's a lot of branches which interact with each other, intersect each other, and it's a little hard to navigate in this history and to understand the context of these commits because they are separated in the time, and you sometimes not sure when this commit was done and which commits surrounds this commit. For example, here you can see a lot of branches intersect each other, but if we scroll down later, we can see much more branches going in parallel. That is why I prefer the workflow which force developer to rebase your feature branch on the latest changes from your master branch to make and merge and make explicit merge commits to make it clear that feature starts here and feature ends here, and you not spread those commits in time. It has some downsides, but I would like to see such history in many projects, and it really helps, in my opinion. Yep. And now we already created our new workflow based on simple Git Workflow plus some ideas from GitLab Workflow and some ideas from GitHub Workflow. Yep. Those slides are more just tips for you if you want to remind something from this talk. We deployed everything, and we have useful links here if you want to read additional materials on the Git and Git workflows, and waiting for your questions. You muted your microphone.
Yeah, sure. Andrew, thanks for your speaking. Could you recommend when we can use both of console version or graphic interface, which prefer and why?
Good question. Which client to use, CLI or graphical? I use the client between graphical and CLI. It's some kind of wrapper around CLI client with hotkeys and some generated history and diffs and ability to resolve merge conflicts. When you're starting using Git, it's much easier to use graphical interface. It makes more sense, and it makes it easier to understand how to work with Git. But some graphical clients hide implementation details from the user, and that is why you can lose some insights that you will get using a CLI interface. That is why I recommend you to start using some kind of graphical interface, but duplicate all the actions CLI inside CLI client at least once to understand what happens under the hood of your graphical client. It will make you more thoughtful about what you are doing using your graphical client, knowing what is happening under the hood.
Okay, thank you. And could you explain, is it clear to use Git force push, or if you are not so good in Git, you probably don't do this command?
Okay, probably if you're not familiar with Git, it's kinda risky to use force push, but in reality you always can watch the command called git reflog, and here you can see all the changes you've done, because even when you're removing a branch or doing some merge or rebase, the original commits are still exist in your repository, but the links to those commits can be removed. But you can find these links here, and you can restore all your work using some additional effort, and that is why it's almost always safe to do any kind of operations in Git, because every time you can find your commits and restore them. But when you're starting using Git, better stick with merge and non-destructive commit, non-rewriting history, non-rebasing workflow, and so on. After you're getting more knowledge about Git and about different features, you for sure should use those features, but with great power comes great responsibility. Another question from Andrew Zhurov. What are your top 3 magit features? Good question. I will start from rebase. Interactive rebase, which you see a few minutes ago, is a very powerful feature, and it's much easier than similar feature that can be done using CLI, because it's much more easier to change the type of the commits, to reorder them using hotkeys, and I quite like them. And most important features that I use in magit is feature similar to commit -p, which allows to do the following. For example, I have some changes. Let me introduce some changes. Something here and something here, and I can commit only part of those changes. I can pick those changes using magit, and only those changes will be staged, and after that I can commit only those changes. It's very cool feature because you can make your commits much more atomic. And another very general feature is how hotkeys works in magit. For example, when you're doing fetch, you can type -r, which will add a rebase flag to your pool. And when you're doing push, you can type -f or -n and so on, which will add all those flags to your command that you do. And this is feature that I quite like and use frequently for different commands. And actually, magit covers a lot of features inside Git. Almost all feature that you do in your real life can be done by magit. You can cherry pick, merge, rebase, interactive rebase, pull, push, fetch, reset, revert, and I think a lot more. Here you can see all those features. Even you can operate on work trees, like for example, in the middle of rebase, you was asked to introduce some change. You can create another work tree, do all the changes on work tree, and go back to your main work tree and continue this rebase. It's very powerful. How I merge in Emacs? Actually, you have few approaches. You can see staged and unstaged changes, and in those changes you can pick two options, like took everything from our changes, or took everything from that come with the merge, or using the Vim, which splits your screen into buffers and will show changes on the left and changes on the right, and you pick a change from left buffer or right buffer. It's probably not the coolest merge tools, or maybe I'm not so experienced in those merges, but it kind of works. And I don't do a lot of changes because all my commits so atomic that all merge conflicts, even if they appears, can be finished pretty easily. Yep. Any other questions?
Okay, maybe last one question is, you prefer to use atomic commits instead of big huge commits? Why, and do you think it's a long history then you have small commits?
Good questions. Yes, it will increase the number of commits inside history, but if we look at our history graph, those commits will be growed by the feature, and that will make it easier to navigate in such history. We can just scroll and see which features was introduced by watching at the name of the branch. That is why it's not a problem that our history is long, because we can track our changes by name of the feature branch. It's a first thing. The second thing, that when you make atomic commits, and for example, you change a greeting message, but later we decided, oh, it was an error, and those message should be different, and you need to revert this commit. You can easily do it without reverting support of CLI arguments for the language and CLI arguments for person name. That is why atomic commits good, because you can revert them, or to reset them, or to do something else, cherry pick, or to different branch, without actually working with all those crappy stuff that you put in a huge commit. Yeah, that is why atomic commits are very cool, and it's a good idea in general when you make a small meaningful message for commit and small meaningful body for commit. It works together very good. You see at the message, and you see what you already understand what inside commit. Because, for example, if you have few features incorporated in what commit, you can't write a proper commit message, because it will be something, we added feature 1, feature 2, feature 3, and feature 4. It will be very long, and you can't understand from commit message what inside it. But if you commit pretty small, you can write a correct commit message for it.
Okay, thank you, Andrew.
Yep. I think that everyone who wanted to ask question already did it. And I am glad that we have so many viewers and so many interaction with you guys today. It was pretty cool. I'm glad that everyone here was so active. I'm glad that Leonid joined us today. Thank you so much, and we'll see you next time. Bye.
See you, Andrew. Bye bye.